today we are going to discuss about digital radiography and the types of digital imaging systems that are available. Okay, you can refer this chapter from Modern Digital Assisting, 39 chapter, and the page numbers are here, two page numbers. Okay, so digital radiography, it has been used in dentistry since 1987 and it has improved tremendously over the time. The digital radiograph that were available before and now, the quality is very much improved. The precision, the sharpness also has improved, and we have more number of diagnostic tools to find out the changes related to the teeth. So when this digital radiography was introduced, the term digital images were reserved for radiographs that were used unlike the films. Okay, what do you mean by that? So an image that we see which has been taken or procured from a digital imaging system, we say it is a radiographic image. But when we say a film and then we take a radiograph, we say it's a radiographic image. Okay, a radiographic or digital image is more precisely used for digital image, and radiographs are the term more precisely used for x-ray films. Okay, so radiographic or digital images using sensors. Okay, and the radiographs using films. Okay, small difference, but to be precise, you can use these two terms separately for the images that they give. Now, the digital images, they are not precisely radiographs, but electronic signals that are captured by the sensors and displayed on a computer monitor almost instantaneously. So, as you have been using the exposures in the labs and in the clinics as well, you'll be knowing that as soon as you do the exposure, immediately you see the image on the screen. So these images can be emailed to insurance companies or other dentists for consultation as per the requirement. The hard copies of these images can also be printed, or it can be copied to a compact disc or a flash drive. So this enables in better recording of the images. So if you are using a film-based radiographs, then what are you going to do? You're going to develop the radiograph, then fix it, dry it, and finally you can use that for the dentist. So only one person views it. For the insurance company, you have to either use a duplicate film or you have to do double radiographic exposure if required. So, with the help of digital imaging, we need not do the double exposures. We need not save a paper file and a hard copy. We can always save a hard copy which is stored in the archives of the digital imaging system. So archives are storage spaces inside the computer or in the system which we use it for storage of large data. Okay. Now, a conventional X-ray machine, it is still required to do the exposure. Only the receptor changes. So the image receptor changed from films to the use of sensors. But the X-ray machine is the same. The exposure factors are also changed. Okay. If you see the control panel, when you use a film based imaging, the exposure factors are more. If you use a sensor based imaging, the exposure factors are less. The position of the image receptor, whether it's a sensor or whether it's the phosphor storage plate or whether it's the film, all of these are identical without any change in the position of these image receptors. So, in addition, strict infection control measures, including fluid impervious barriers, must be used because the sensors and PSPs are reused every time and again, and they cannot tolerate heat sterilization, so they cannot be autoclaved. For the films, we already have a plastic wrapper or barrier which we place it as the film packet and the film is inside the packet. So there is no cross contamination when we use a conventional films. But because we use sensors repeatedly for different patients, it is very important that we prevent the progress of a cross contamination that can occur. So, how to do that? By using a fluid impervious barriers. Okay, so strict infection control protocols are required for the sensors because they cannot be sterilized because they are very sensitive to heat. So, step by step procedures are required for the use of digital radiography, which differs from manufacturers to manufacturers. And therefore, it is critical to refer to the manufacturer's instruction booklet for information concerning the operating system, equipment preparation, patient preparation, and exposure factors. Okay, so the sensors, they are different in the shape, in the thickness by different manufacturers, and the different manufacturers will have some specific instructions how to use the sensor or how to use the sensor software. Okay, so we have to always go to the sensor manual, especially if you are changing your workplace and you're going to a new location where you are practicing a digital radiography. You have to know what are the instructions that you have to follow to use that particular sensor from the particular company. Okay, so that is important because the specifications may slightly change for each of the sensor. Specification means the thickness, the color, the edges, all these features. So there are two basic methods to acquire digital X-ray images. So one is the direct imaging method, which we use in the labs and clinics. Then the second one is the indirect imaging method, which is used with phosphor storage plates, or you can also call them as phosphor stimulable plates. So, the details about the indirect imaging we'll be learning in the next module in DAS 321. Okay, so we'll discuss more in detail about the direct imaging here. So, a direct digital imaging. So, what is the difference between a direct and an indirect? So, in indirect, the image does not appear on the computer immediately, but in direct, the image appears on the computer as soon as you do the exposure. It's only a matter of seconds. So, in direct imaging, a solid state sensor is the image receptor. It's also called as CMOS or CCD receptors, which is for complementary metal oxide semiconductor or charged coupled device. So these terms it will be appearing in the further discussion topics. Okay, so it contains X-ray sensitive silicon chip with an electronic circuit embedded in the silicon. So, what do you mean by that? So, if you have seen any electronic circuits or, for example, motherboard of a computer, you see a green panel on which there are a lot of circuits that is protruding out with small connections inside that. Okay, so these are called as electronic circuits or substrates. Okay, so these they are sensitive to X-rays and they are made of silicon. Okay, so the silicon material will help in the conduction of electronic signals. So that is why we use silicons in these sensors. So there are two major types of sensors: complementary metal oxide semiconductor and charged coupled device. The most commonly used sensor is the CCD, which is also used in extraoral imaging as well for panoramic or cone beam volumetric imaging, that is called as CBCT imaging, which is a three-dimensional technique again. Okay, so the one that we use in the lab is a CMOS, complementary metal oxide semiconductor. Okay, some CCDs are wireless, and the others they have a cable connected to the sensor and the computer. So the wireless type of sensors, they use radio frequency transmission, like the ones that you use for mobiles. Okay, so here the wireless sensor, it has radio frequency transmission to transmit the image to the computer. So this takes place with the help of the radio waves. Like how you call from mobile to mobile. If you call one person from your mobile, the other person can receive your voice signals. So in the same way, here also radio waves transmit the signals to the computer. So parts of a CMOS sensor. So you have an outer housing that is called as the front housing. It is usually flat, which comes in contact with the patient's teeth on the palatal side or on the lingual side. The sensors or the films, they are never placed on the buccal side unless there is some technique modification indicated. Okay, so all the X-ray exposures are usually done on the palatal or the lingual side with the flat surface of the sensor contacting these areas. So after the front housing, so definitely you're going to have a back housing as well. It's also called as rear housing, marked by 3. So front housing is 1, rear housing is 3. That is the back housing. Housing means the area which is covered, covering the main parts of the sensor. Okay. Number 2, as marked by the green color, is the electronic chip, which mainly has silicon. Okay, so the silicon will help in the transmission of the signals. Now, number 4 is a scintillator. So, scintillator has some similar functions like the intensifying screen that is used with extraoral imaging. So, extraoral imaging with the help of films, we usually place the films sandwiched between two intensifying screens on the other side, which is supported by the cassettes. So, here, this function of intensifying screen is done by scintillator. So, if you remember, intensifying screens, they take up the X-rays and convert the X-rays into visible light photons. This will reduce the radiation exposure to the patient. Similarly, the scintillator, it takes up the X-rays and converts that into visible light signals. So these visible light signals, they pass through the fiber optic plate. So if there is any irregularities or non-uniformity of the radiation passing through the fiber optic plate, or if any X-rays try to penetrate through the fiber optic plate, the fiber optic plate will prevent the passage of these unwanted X-rays, okay, or unwanted visible light signals. So the fiber optic plate, it acts as a small barrier to protect any X-ray beam to reach the substrate, because substrate, that is the electronic chip, it is very sensitive to X-rays, so it can get damaged very fast. Okay, now number 6 is the CMOS sensor, complementary metal oxide sensor. So the difference between a complementary metal oxide sensor and a CCD, the main difference is that the CCD will not have number 5, that is fiber optic plate. Okay, it will have a front housing, it will have a back housing, it will have an electronic chip, it will have a scintillator and the CCD sensor without a fiber optic plate. That is the basic difference between a CMOS and a CCD. So the parts of a CMO sensor, as we discussed now, the front housing, it contacts the patient's teeth. Hence, it should always have a comfortable design. It should not have any roughness to make the patient uncomfortable or induce gagging when we place the sensor. Electronic chip, it transmits the electronic signals directly to the computer with the help of radio waves. Rear or back housing, it has a protective shield. That means it has a lead lining to prevent the backscatter of radiation, same like the ones that we use in the film. So it has the same purpose. So the rear housing is the only part of the X-rays that can prevent a backscatter. The front housing cannot prevent a backscattered radiation. Okay. Now, scintillator, it converts the X-ray beam into visible light. As I said, it has the same functions like the intensifying screens that we use in the extraoral imaging. Fiber optic plate, it transmits the light precisely to the sensor surface, reduces the noise. That means the unwanted X-ray beam penetrating the sensor or unwanted visible light that is getting scattered and which can cause non-uniformities in the sensor. Okay, so these non-uniformities which can affect the quality of the image, these are called as noise or radiographic noise. So radiographic noise means, for example, if you have a classroom with the students only and the teacher is not there, then you can hear the different sound waves of each student which occurs at different wavelength. So someone from outside the room can hear noise. Noise means unwanted or non-uniform sounds coming. Okay? But when a teacher comes inside the classroom, the students try to listen to the teacher. So they are more fine tuned. If something is asked to a student or the group of students, they answer uniformly. Okay, so it is a sound. So sound doesn't have unwanted voices. Okay, but a noise has unwanted noises or non-uniform noises to be precise. Okay, so in the radiography also, when you see any unwanted areas that can compromise the quality of the image, we call them as noise. Okay, so it's called as a radiographic noise. Like, for example, when you do the processing of the X-ray film, if you accidentally put the finger inside the surface of the film, then you get the fingerprint on the film when you develop the radiograph. So this is called as a radiographic noise because it's unwanted. The film should not have anything on its surface apart from the image that can be seen. Okay, so radiographic noise can be removed with the help of this fiber optic plate. Now the sensor itself, it converts the visible light into electronic signals. So what happens when an X-ray falls on the sensor flat surface, that is the front housing, it is going to go to the scintillator. Scintillator converts it into visible light. So visible light along with maybe one X-ray photon, it will go towards the fiber optic plate. At the region of the fiber optic plate, only visible light is allowed to pass through and the X-rays are prevented. Then from there, the visible light reaches the sensor. So in the sensor, they are converted that into electronic signals. So electronic signals, they are taken up by this electronic substrate, which helps in the transmission of the signals to the computer. And finally, we have the back housing or rear housing. This is lined with lead shield or lead coat to prevent a backscattered radiation. Okay, so these are the parts of a CMOS sensor. Next is the phosphor storage imaging. It's also called as phosphor storage plates or photostimulable phosphor plates. Okay, any of these two terms represent the same thing. Its short form is PSP. So this belongs to indirect digital imaging. So if you see the image shown on the right side up, you can see that it is available in the sizes like your X-ray film itself. You have 0, 1, 2, 3, and 4. So all of them are PSP plates or PSP imaging system. There is no size 4 in a direct imaging system. In PSPs, that is the indirect ones, we have size 4. So, occlusal radiography, in which you take the radiograph by placing the sensor or the film on the occlusal surface of the tooth, can be taken using the conventional X ray film or this PSP plate. The advantage of this PSP plate over the sensors that we can find in the clinics is that it is thin and flexible. The sensors that we use in the lab, as you know, it is thick and rigid. It does not move, it does not flex. Okay, so it is also coated with phosphor crystals. That is why the name phosphor storage imaging or phosphor storage plate. They store the energy of the X rays photons for some time in the same scanner, and this is the only type of sensors which can store energy. Okay, so PSP plates are the only type of sensors which can store energy. When the PSP plates are exposed to radiation, they will store the energy for some time until the time it has been processed. Okay, processed is not using the chemical processing. We are going to use a scanning device to scan the images from the PSP systems. Okay, so that is how it differs from a direct imaging. So the problem also exists when you have to scan and get the image. There is some delay in the imaging time. Okay, so a direct digital sensor like the one that you use in the lab, it gives you instant images on the desktop or the monitor, but whereas an indirect one, you need to scan it to take the images. Okay, now digitizing images. So, film based radiographs may be digitized for viewing on the computer. That means the old patient files in which there are films, and you want to change all the paper based file systems in your clinic into a digital one. Then, what you can do? You can use a digitizing machine. Okay, so what is that? So, here you are going to use a scanner. It's called as a duplicating machine or a duplicating equipment. So you have a light box as well. Film is placed on the duplicator light box and they are scanned to get a digitized image. So the type of indirect digital imaging, this is slightly less detailed than the direct digital imaging. Okay, so what do you mean by the previous slide? In the previous slide, it means that a normal film can be converted into a digital image by scanning the film itself. So direct imaging software programs, these are available and it comes in various shapes and sizes. Okay, so the most computer software programs, they are used incapable of performing electronic image enhancements. Okay, so they are capable of performing these electronic image enhancements. What do you mean by that? Image enhancement. Enhancement means to increase, to make it better. So image enhancement means to make the image better. So this means that the operator can change the contrast, change the brightness, the image size, the sharpness, the inversion, converting a white area into black and black into white, as well as you can pseudo color the areas which you are looking at. Okay, for example, you can check the root canal and color it and invert the color as well. Okay, so these are the enhancement features that is available. Some of them which is listed here: air presence, change to contrast, in which you can see more shades of white and gray. In the second one, you can see the pseudo color alteration, and in the third one, you can see the inversion of images. Okay, so these are the settings that are possible with a digital imaging. Advantages and disadvantages of digital radiography. So advantages, they include they can be immediately viewed rather than doing all the steps of chemical processing using developer, fixer, rinsing, washing, drying, and then finally mounting. So all these things are done with a single click. Less radiation exposure, 70 to 80 percentage of radiation is less compared to the film based imaging. There are no chemicals used here. Ability to enhance the image exists. Communication with other dentists by the help of emails or other social media platforms can be exchanged. Then no more lost film. That means you need not preserve the hard copy of the film. You have the soft copy, you can print them anytime it is required. Remote consultation capability. It's called as tele-dentistry. Tele-dentistry means you are sitting on other end and I am sitting in the university now. Okay, so we are able to communicate to each other. So this is called as tele-dentistry. Okay, so remote consultations. It doesn't matter where you are and where I am. You get the consultation done with the help of the digital imaging systems. Okay, that is an advantage that we have here in digital imaging. So, what is the disadvantage that we can have? One is the cost. Converting precious records to digital, it takes time and it is a tedious job. Tedious job means it requires more hard work. Then, learning the computer software is also one skill that you need to master. Thickness and rigidity of the sensors. The sensors are thick and rigid, so the patients may not completely cooperate to the dentist or the assistants while taking the radiograph. Okay, then infection control. In the films, we do not require infection control. We need to follow just the steps, need to do the processing, everything with the infection control. But in the case of sensors, the starting point of the process itself, we need to do the infection control, like fluid impervious barrier, which is a requirement without which you cannot take a radiographic exposures. Okay, so this is a very short chapter.